Hello, and welcome to a concept review video for CSCI 2824, Discrete Structures. To help you gain a little bit of a better grasp on complexity and bounds, we'll be going over visualizing a big O bound on a graph. So first of all, let's remember, what is big O? When we have some function f of n, we say that f of n is big O of another function when it grows no faster than that function. So, for example, suppose this is our function. We might have some other function, say n cubed, for which it is the case that f of n is always less than or equal to n cubed. This means that f of n is big O of n cubed. However, we'll notice that the difference between our function f of n and n cubed is rather large. In fact, it's so large that n squared actually fits in there as well. We notice that's the case that f of n is always less than or equal to n squared as well, meaning that f of n must be big O of n squared. Because the distance between f of n and n squared is smaller than the distance between f of n and n cubed, we actually prefer the bound with n squared. This is what we call a tight bound. Now, when you're finding big O, you've also been asked to find a c value. So what is that c? Well, again, let's suppose we have some function, f of n. The c value is just some constant on our bounded term. So, for example, in one of your homework problems, you might have said, oh, f of n is less than or equal to 68n squared. Well, we know that regular n squared just looks like this. And by multiplying it by a constant term, we would get 68n squared. So the c value is just the constant that's always out in front. Now, you've also been asked to find what is a k value. K is a range. So this is when our bound holds. For example, suppose this is our function, f of n. Let's say we have some other function that grows like this. And the intersection point is at 4. We notice that f of n is only less than or equal to g of n when n equals 4. This is also our k value. We can say f of n is big O g of n when k equals 4. When you understand these terms and are able to visualize them, understanding big O and complexity becomes much easier. Thanks so much for watching, and good luck.